The next thing we are looking here is the low pass filter. So if we had the high pass filter with the capacitance on here and the resistance down here, and then the output voltage is over the resistance, that was the high pass. Then it's the other way around on the low pass. So we are taking out the voltage over the capacitance, and then it's a low pass filter. The equation for the cutoff frequency is exactly the same. And then it's a classical voltage division. And now I have like the R1 here, and this is replacing the R2. And then I have the reactance of the capacitance, which is replacing the R2. And then in the classical voltage division equation, the reactance is in here. And now it's your time to calculate with these values. With the same 30 Hertz, 3000 Hertz, and which one is going through. So the students were calculating that what comes out when you feed in the signal with the 30 Hertz, and then it comes out almost with the original amplitude. So if you put in amplitude 1, it comes out the sinusoidal wave with the amplitude 1, comes out with an amplitude 0.78 volts. So almost like the original. Actually, what comes out if you put here a DC voltage, so a constant voltage, let's say 5 volts. If you put here in 5 volts and it doesn't change at all, what happens? There is some kind of current flowing, it's loading, charging this capacitance. There is no current in here, this is just the open contacts on my connector here, no current in here. So current is charging this capacitance, and then it's charged to 5 volts, and the 5 volts stays here. So this is charged into 5 volts, and then after that, the current disappears. No current more when it's charged. And you have the 5 volts out here. So the 5 volts also in the output, if you connect a 5 volt in here. And then if you connect there a high frequency signal, what comes out? The high frequency signal, like 10,000 Hertz or whatever, it goes quite easily through a capacitance because it's a high frequency. And this is almost like a 0 ohm resistance then. And if this would be like a 0 ohm resistance, there is like a direct connection in here, then there is 0 volts over here. So nothing comes out if you have really high frequency. Yeah, that's how it works. This is a low pass filter. And like now I can show you that what are the results from the calculator. So we had an earlier calculation in here. I think I'm a lazy guy and I'm modifying this one. This one was with 30 Hertz. So I have here might be correct. So this is the reactance. So the reactance in here. So the voltage times the reactance time divided by the resistance plus the reactance. So yeah, unnecessary. axis. So there is my reactance. Is that's unnecessary. I think now it's correct. This is my reactance divided by the resistance plus the reactance and multiplied by the original voltage, which was the 1. And I got 0.779 volts as an amplitude out. So that one is passing almost like the original because it's a low frequency, 30 Hertz. And then I copy it again. And then I will put there the 3000 Hertz, like I'm asking here, 3000 Hertz. What happens with 3000 Hertz? Like this. Should come out with the low voltage. Yeah, I get 0.034 volts. Yes, and the students have also, I can see from the chat window that the students have the same result. Fine. So that was the calculation for the low pass filter.